right, so first one I want to look at is on the 4th page, the one on the top. So it's B on the last page. So this is from the homework yesterday. I have 1 minus sign on the bottom. Can I use my Pythagorean identity? Why not? Because it's not sine squared. But because I have a 1 and a sign, maybe I want to make this a Pythagorean identity. So is there anything I can multiply to change this? It's opposite. Yeah, so 1 plus sine theta. If I multiply that to the bottom, I have to multiply it to the top too. So my goal on the bottom is try to get this to be a sine squared, so then hopefully I can use my Pythagorean identity. So on the bottom, I have to FOIL it out. So I have 1 plus sine minus sine squared. So I just FOILed the bottom. So the signs in the middle cancel, so I have 1 minus sine squared. Now going back to my Pythagorean identities, can I change 1 minus sine squared to anything? So I can change this to be cosine squared. So get rid of it, make it cosine squared. So now on the top, I have cosine squared theta times 1 plus sine theta over cosine squared. What can I do next? I can cancel out the cosine squared. Since the cosine squared is being multiplied on top, I can cancel it out with the cosine squared on the bottom. So what am I left with? 1 plus sine theta. And that's it. There's nothing else we can do there. So that would be our answer. So let's take a look at D. What can I do for this one? So I can change cosecant to 1 over sine. Can I change tangent to sine over cosine? And then I have a cosine at the end also. So I can make it cosine over 1. Do I have anything that'll cancel? The sine on top cancels out with the sine on the bottom. Anything else? Cosine on top cancels out with the cosine on the bottom. So what am I left with? 1. What can I do first for this one?
Change secant to 1 over cosine squared.
I can do that. So 1 over cosine squared. I can make tangent sine over cosine. I can keep chain split. So here I have cosine over sine. So anything cancels. So cosine on top just cancels out with one of the cosines on the bottom. So I still have 1 over cosine times sine on the bottom. So this would be tangent minus 1 over cosine times sine. Nope. What else can I do? I can change the other tangent to sine over cosine. So my goal is to try to combine these together. In order to combine fractions, what do I need? A common denominator. I can do that. I can multiply the first fraction by sine over sine. So whatever we multiply to the bottom, to get that common denominator, we also have to make sure we multiply it to the top too, so we don't change any values. So what's sine times sine? sine squared. So I have sine squared over cosine times sine minus 1 over cosine times sine. Can I combine these together? Yeah. I have a common denominator, so I can just subtract the top. So I have sine squared minus 1 over cosine times sine. Sine squared minus 1 looks like one of my Pythagorean identities. What can I change sine squared minus 1 to? So I can change that sine squared minus 1 to be negative cosine squared. So I have negative cosine squared over cosine times sine. What can I do next? So the cosine on the bottom just cancels out with one of the cosines on top. So I'm left with negative cosine over sine. And what's cosine over sine simplify to? So negative cotangent. That would be our answer. For this one in the beginning, I changed this to have a denominator of tangent, so I multiplied the top and the bottom by tangent over tangent, and then combined them, which I think it's a few less steps if you did it this way, but changing everything to sine and cosine and then combining it works out too.
Wait, what'd you do there?
Here, like the way I did it, so I didn't start it out the same. I made it tangent over 1, and then multiplied the top and the bottom by tangent over tangent, and then combined my fractions together, because then I had a common denominator. So I ended up on the top with tangent squared minus secant squared, and then changed that to the Pythagorean identity. Yeah. So again, these problems have different ways of doing it. Some ways are shorter than others, but you'll end up with the same answer. What can we do first for number 2? I can change the top to cotangent squared. So I have cotangent squared over cotangent. What can I do next? Perfect. So the cotangent on the bottom just cancels out with one of the cotangents on the top. So I'm just left with cotangent. Awesome. So 5.2, we're continuing with our trig identities, but today we're going to be verifying them. So in our equations for these types of questions, or these types of questions are actually equations. So we have an equal sign. So we'll have like some trig identity over here is equal to some trig identity over here, and we have to make them be the same thing. So what we would do is we put a line down the middle, and we just work with one side at a time. You can't add or subtract something from one side to the other. You can only simplify one side at a time. So down here it gives us some steps. So it says work with one side of the equation at a time. This is the most important. You cannot go from one side to the other. And it's often better to work with the more complicated side first. It's easier to simplify the harder side than it is to expand something that's already just sine. So we want to work with the more complicated side first. So we want to look for opportunities to factor an expression, add fractions, square a binomial, or create a monomial denominator. Look for opportunities to use the fundamental identities, so that's like our sine, cosine, the reciprocal ones. And then when the preceding guidelines do not help, try converting all terms to sine and cosines. And the fifth step is to always try something. Even making an attempt that leads to a dead end provides insight. So always try something. So looking at example 1, I'm going to put a line down the equal sign. Which side do you think we would want to work with first? The left side, because it's more complicated. It's going to be easier to simplify the more complicated side than it would be to expand. So we have our trig function here. Our goal is to simplify this and make it sine squared. So these types of questions it pretty much gives us the answer. It tells us what we have to simplify all of this to. So our answer, what you're graded on, is the work that you do. So you know, just by looking at this question, we're going to end up simplifying this left side to be sine squared. So what you're graded on is all the work that you do. So just make sure you are giving me work, okay? So what do you want to try first? I can use the identities. What does secant squared minus 1 change to? Tangent squared. So I'm going to change the top to be tangent squared. So I can change tangent to be what? I can change tangent to be sine over cosine. And change secant to be what? 1 over, they're all squared. So sine squared over cosine squared. And then secant squared becomes 1 over cosine squared. I'm going to rewrite it down here just to have a little bit more room. What would I do next? Change, flip. So we keep the top, change to multiplication, and flip the bottom. So we are multiplying by the reciprocal. Awesome. What happens next? The cosine squareds cancel. And what am I left with? Sine squared. And sine squared is equal to sine squared. So then we're done. All right, so let's look at example 2. So I'm going to put a wall down the middle because I can't go from one side to the other. Which side do you want to work with first? The right side. So we see on the right side we have 2 fractions. My goal is to get 2 secant squared. So I know that I'm going to have to combine these just to be one term. This is, it's the same thing as theta. It's just like an alpha, so it's just a different symbol. But it'll either be like, you'll either see theta, the alpha, sometimes like it'll say x, just same thing. What can I do first? Any suggestions? Make a common denominator. So what do I have to multiply in order to get a common denominator? The conjugate. Well, I'm going to multiply by the other denominator. So I have 1 plus sine squared that gets multiplied on the top and the bottom. Or 1 plus sine, sorry, not squared. 1 plus sine gets multiplied to the top and the bottom on the first one. And 1 minus sine gets multiplied to the top and the bottom in the second. So in my first fraction, I have 1 plus sine. I have to FOIL out the bottom. So I end up with 1 minus sine squared. Same thing with the second fraction. I have 1 minus sine on top over 1 minus sine squared on the bottom. Now that my denominators are the same, I can combine them. So I'm just going to add the numerators together. Keep my denominator the same. What happens when I add the numerators? What do I get? 2. Because the signs cancel. Sine minus sine cancels out. And I still have that 1 plus 1. So I'm left with a 2 on the top. And on the bottom, I have 1 minus sine squared. Can I change that 1 minus sine squared to anything? cosine squared. What can I do next? Awesome. 2 over cosine squared. I can flip the cosine squared to be secant squared. That 2 just stays on top, so it's 2 secant squared. What was my goal? 2 secant squared. The left side. Left side's a little bit more complicated, so let's work with that one first. What do you want to do first? So I can change this to be secant squared. Can I change the cosine squared minus 1 to anything? Awesome. Negative sine squared. What can I do next? So I can change secant squared to be 1 over cosine squared. I can multiply these together, so it'd be negative sine squared over cosine squared. What would I do next? Change it to negative tangent squared. Perfect. Which is the same thing that I was looking for. So I'm going to put my line down the middle. Which side do you want to work with first? I would say the left, just because I have 2 terms on the left that are separated by a plus sign, and 1 term on the right. So I know that I'm going to have to combine these together somehow. What do you want to do first? I can change the tan to what? I could change it to 1 over cotangent. Probably would have done that. Again, different ways that we can do this. What do you want to do next? Find a common denominator so we can add them together. So what do I need to multiply to get a common denominator? Multiply the second one times cotangent over cotangent. So I end up with cotangent squared on the top over cotangent on the bottom. Can I add these together now? Yeah, now that I have a common denominator, I'm going to add the tops together. So I have 1 plus cotangent squared over cotangent. When you have a common denominator, do I add them together? The denominator stays the same. What can I do next? Change 1 plus cotangent squared to what? Cosecant squared. So I have cosecant squared over cotangent. What do you want to do next? I can change the bottom to cosine over sine. And then what? Okay, I can change the top to 1 over sine squared. And then I want to keep change flip. Does anything cancel? So a sine cancels out with one sine from the bottom. So then I'm left with 1 over sine times cosine. What else can I do? So what is 1 over sine? So 1 over sine is cosecant, and 1 over cosine would be secant. Which is almost exactly what I was looking for, but when you're multiplying, you can switch the order. So it's like saying 2 plus 4 and 4 plus 2. They're the same thing. So I'm just going to switch them just so it's exactly the same as the left side. So that is the same thing there. If you get stuck on one side, let's say we got stuck here and we didn't know what to do. You can stop on one side, go to the other, and then start simplifying that side too. You just can't go like across the line. So I can't like add something over here to the other side. So can't cross the brick wall, but if you get stuck here, you can always start simplifying the other side too. That would work. Just can't move things from one side to the other.
So that's your final answer?
So that's our final answer. Once you get something that matches, then you're done.